In this episode of Big Kahuna videos, Michael and Chad reveal the concepts behind chemical reactions and stoichiometry. Every day, chemical reactions occur inside and around you, ranging from washing hands, lighting a matchstick, brushing your teeth in the morning, or eating in the evening.
In a chemical equation, there are reactants that undergo a reaction to form the resulting products.
In word equations, the names of the reactants go to the left, followed by a yield sign or arrow, and the names of the products to the right. Each substance in the reactants and the products side, there is more than one, are separated by plus signs.
While word equations are a good way of interpreting chemical reactions, chemical equations, however, are better because they were preferred by chemists. In order to balance a chemical equation, both the reactants and product side must have an equal number of atoms in order to follow the law of conservation of mass, so that mass is conserved.
On the other hand, skeleton equations are chemical equations that do not show the relative quantities of reactants and products. So these equations must be balanced.
To balance a chemical equation, first, determine the correct formulas for the reactants and the products. Then write its skeletal equation. Then determine the number of atoms for each element being in both the reactants and the product side. Ensure that the element has the same number of atoms for the reactants and the product side by using coefficients. Now that we know how to balance chemical equations, let's look at the 5 general types of chemical reactions.
Combination reactions are when two or more substances react to form a single new substance.
Decomposition reactions are a chemical change in which a single compound breaks down into two or more simpler products.
In a single replacement reaction, one element replaces another in the compound. Iodide to form sodium bromide plus and iodine. Bromine replaces iodine to form a different compound. There is a catch. The element must have a higher reactivity than the other to replace an element. The activity series of metals can be referred to in order to determine if an element can make a replacement. Otherwise, if the element cannot, then there is no reaction. Now let's give a relatable example. Let's say we got Donald Trump reacting with Barack Obama in the White House. Now, in this chart, since Donald Trump has a lower reactivity than Barack Obama, then Donald Trump cannot replace Barack Obama, and there's no reaction. Now, let's say we put Bernie Sanders. Now, look, he has a higher reactivity than Barack Obama. Thus, Bernie Sanders can replace Barack Obama in the products.
A double replacement reaction is a chemical change involving an exchange of positive ions between two compounds. They generally take place in aqueous solutions and often produce a precipitate, a gas, or a molecular compound such as water.
A combustion reaction is when an element of compound reacts with oxygen, producing energy in the form of heat and light. The product usually has carbon dioxide and water unless the supply of oxygen is limited, which would be an incomplete reaction.
The best way of predicting the products of a chemical reaction is by observing the amounts of elements and compounds that are reacting.
As an illustration, in a combination reaction, two or more reactants react to form just one product. In a decomposition reaction, a single reactant that is a compound reacts to form two or more products. In a single replacement reaction, an element plus a compound will be the products of the reaction. In a double replacement reaction, two ionic compounds are reactants, and two new reactants are the products. In a combustion reaction, the reactants are oxygen, carbon, and hydrocarbon. Its products for a full reaction are carbon dioxide and water.
Balanced equations are used every day in production and can also provide the same quantitative information as a recipe.
Stoichiometry is the calculation of quantities in chemical reactions. Balanced chemical reactions can be interpreted in terms of number of atoms, molecules, or moles, mass, and volume. So in this equation, we got nitrogen gas reacting with hydrogen gas to form ammonia. for nitrogen gas, we've got 2 atoms, 6 atoms for hydrogen gas, 2 atoms of nitrogen, and 6 atoms of hydrogen for ammonia. For the molecules, they are the same as its coefficients. So nitrogen gas has 1 molecule, hydrogen gas has 3 molecules, ammonia has 2 molecules. Nitrogen gas has 1 mole, hydrogen gas has 3 moles, ammonia has 2 moles. The mass of nitrogen gas is 28 grams, and the mass of hydrogen gas is 6 grams, and the mass of ammonia is 34 grams. If you add the reactants together, you get 34 grams, and which does equal the 34 grams of the product. Therefore, the law of conservation of mass is obeyed. The volume for nitrogen gas is 22.4 liters. The volume for hydrogen gas is 67.2 liters. The volume for ammonia is 44.8 liters.
An essential concept of stoichiometry is mole ratios that can be used to convert between moles of reactants and moles of the product. Balanced equations like recipes are limited to the sufficient quantities of all the ingredients available.